Now we start the laser beam characteristics. The important characteristics of the laser beam are diagonality, negligible divergence, high intensity, high degree of coherence, and high monochromaticity. First is the directionality. The convenient light source emits the light uniform in all directions. When we need a narrow beam in a specific direction, we obtain it by placing a slit in front of the source of the light. In the case of laser, the active material is in the cylindrical resonant cavity. Any light that is traveling in the direction other than the parallel to the cavity axis is eliminated, and only the light that is traveling parallel to the axis is selected and reinforced. Light propagating along the axial direction emerges from the cavity and becomes a laser beam. Thus, a laser emits light only in one direction. Second is divergence. Light from the conventional source is spread out in the form of spherical wave front, and hence it is highly divergent. On the other hand, the light from the laser propagates in the form of plane waves. The light beam remains essentially a bundle of parallel rays. A small divergence that exists is due to the diffraction of the beam at the exit mirror. A typical value of the divergence of the helium-neon laser is 10 to the minus 3 radians. It means that the diameter of the laser beam increased by about 1 mm for every meter in the travel. The extent of the divergence can be estimated as a simple method as follows. If the diameter of the spot produced by the laser on the screen, which is held at two different distances from the laser, are measured, then the angle of divergence given by phi is equal to d2 minus d1 upon L2 minus L1, where d1 and d2 are, d1 is the spot diameter at the distance L1 and d2 is the spot diameter at the distance L2. Next is intensity. The intensity of the light from the conventional source, it decreases rapidly with the distance as it spreads out in the space. Laser emits light in the form of the narrow beam with energy is concentrated in a small region of the space. Therefore, the beam intensity would be tremendously large, and it contains with the distance, is constant with the distance. The intensity of the laser beam is approximately given by L is equal to or I is equal to 10 upon lambda upon square into P, where P is the power radiated by the laser. To obtain light in the same intensity from the tungsten bulb, it would be have to raise the temperature of 10 to the power minus 4 into 6, 4.7 10 to the power minus 6 Kelvin. Next is the coherence. The light that emerges from the conventional light source which combines with each other random manner, the resultant light is incoherent. Coherence length is one of the parameters used to measure the coherence. In the case of laser, a large number of identical photons are emitted through the stimulated emission, and therefore they will be in the phase with each other. The resultant light exhibits a high degree of the coherence. Then, important point is the monochromaticity. If the light coming from the source has only one frequency, having single wavelength of oscillation, the light is said to be monochromatic, and the source is a monochromatic source. Light from the traditional monochromatic sources spread over the wavelength range 100 angstrom to 1000 angstrom. On the other hand, the light from the laser is highly monochromatic and contains a very narrow range of a few angstrom, less than 10 angstroms. Now, there are few applications. Laser are used in the CD players, laser printers, laser photocopiers, optical floppy disk, optical memory cards, etc. The large intensity that possible is in the focus output of the laser beam is directionality. It makes very important. Sometimes it is used in the welding. Welding is the joining of the two or more pieces into the single unit. If we consider the welding of the two metal plates, and the metal plates are held in contact and their edges and the laser beam is made to move along the line of contact of the plate, the laser beam hits the edges of the two plates of their melting point and cause them fuse together. They are in the contact. Other is the drilling. The principle of underlying drilling is the vaporization of the material rate at the focus of the beam with laser. One of the real holes in the small extent 10 micrometer in diameter. For drilling, the energy must be supplied in such a way that the rapid evaporation of the metal takes place. These are the very important points which can be laser used. And these are the few numericals that the wavelength of emission light is 6000 angstrom, and the coefficient of spontaneous emission 10 to the power 6 times per second. This is the coefficient of the stimulated emission. The formula is given B21 is equal to this value, and place the value and you will get the result. At the same next question is at what temperature are the rates of spontaneous and the stimulated emission are equal? Lambda is equal to 5000. And in this case, if the rates of the spontaneous emission and the stimulated emission are equal, then R1 is equal to this formula is equal to 1, or e to the power h nu upon k is equal to 2. Place the value of lambda and other things, you will get the result. So you will get at T is equal to 41,558 degree Kelvin. So it is the temperature. Similarly, next question is the length of the laser tube is 150 and the gain factor of the laser material the point is 0.05 cents per centimeter is the one of the cavity mirror reflects 100% light, and what is the required reflection of the other cavity measurement. In this case, the solution is given. Gamma f is equal to 1 upon 2i L ln 1 upon r1 by 2. Place the values and you will get the result. Okay. These are some numericals which were on the basis of laser light. Okay. Thank you.